Welcome, everyone. It is okay. I don't want to hold you too long, so 7:04. I'm going to go ahead and get started. Welcome to the introduction to data literacy. I am LaLauria Canada, one of the librarians on the Atlanta campus. So today, let me share my screen, and I am going to get out of my video. So hopefully by the end of this session, you'll know how to evaluate and critique the purpose of data. And you'll also know how to find general statistical data. So we're going to work on that. And just to let you know that this session will be recorded at the end of the session, maybe later on tonight or early in the morning, I will send all of you a link to the research guide. So the PowerPoint that I'm using will be there, the transcript, and a video will be there for you. And so as we go along, I'm going to ask questions, so feel free to unmute and participate if you like, or use the chat. You can also chat, use that function. And just to let you know, this is a general introduction, and at the end, I'll show you if you want to learn more about how to work with data sets. We have a whole unit that helps with that, and I'll give you the information for that as well. So, what is data literacy? And data literacy is the ability to read, write, and work with data, as well as communicate your findings. So if you know how to read data effectively, that means that you can make sense of quantitative and qualitative information. Of course, the qualitative data is the numerical data, and the qualitative data, data gathered from sources such as, somebody's in the lobby there, okay. And, okay, welcome the person who just came in. And numerical data, non-numerical data is the qualitative data. That's the information you get from sources as focus groups and interviews. Of course, if you know how to work with data, it could be a useful tool in your research paper. Now, you may not, if you're undergrad, first year, second year, you may not be required to actually go out and create your own data, but there are some sets that you can work with, and that can help strengthen the point in your paper. So we'll be looking at how to find some of that. And of course, once you know how to work with data, you need to be able to communicate that in clear and concise language. Okay. You can mute now if you, yeah. Just unmute, if you have a question or you want to answer the question. So why should you care about data? And the short answer is because people lie with statistics all the time. So you need to be data literate so you can recognize the lies and misinformation that's thrown at you. Of course, when you do a Google search on a topic, it's not just presenting good data or results. Everything isn't factual, so you're going to get the junk in there too. And because data is out there, anyone can manipulate and post that data. So that's just one of the reasons why being data literate is a benefit to you and to others who you share information with. Also, knowing what that data means can be the difference in which initiatives support. And it could be the difference in what you spend your money on based on proper data that you receive. So researchers and media lie, mislead with statistics, with selective bias. Sometimes they'll have a small sample size. They may only talk to 20 people. They'll have you thinking they talk to 2,000. So, of course, 20 people cannot represent a large group of people. So that's another reason you have to look out for. There's no diversity in a group of 20 people. So developing data literate skills helps you avoid being misled with these mistakes. Okay, so we've kind of gone over why you should be data literate. Why should you care about being data literate? But for you, what do you think is the benefit of being data literacy? Personally, how does that help you? And again, you can unmute or write something in the chat.
I'll just say what I think.
Okay.
um, I mean, it may be good to know about data literacy because it allows you to break down certain information, you know, that you would necessarily, what, I don't know, like need on a computer or something. It
Mm-hmm.
just allows you to, I don't know.
Yeah, you just you know how to make sense of the information. You can't be misled.
Put it together like puzzle pieces, you know.
Yes, Ingrid, it is good to be aware. Um,
Since it's usually detail oriented. Yeah, yeah,
mm-hmm.
yeah.
Yes, yeah, and you don't want to be fooled just because somebody throws a whole bunch of stuff at you. Thank you. So yes, making sense of complex of competing information. That's that detailed information you were talking about. And you know how to get clear conclusions from the data, um, because two people can have the same data set and still interpret it different, which really, how does that happen? Someone's not deriving clear conclusions. It helps you make estimates for realistic solutions for everyday problems. So we do this all the time in our personal lives, from shopping or deciding where to live or deciding what school to go to. That was probably based on some type of data. Um, so yes, you apply that information to your own life choices and decisions, and you filter out unreliable sources with ease. So that's why you're at Georgia State and not somewhere else, because you made a good decision with the data information you had. Hopefully, with the scholarship you got. Okay. Now, of course, there are benefits and there are risks. So, what is the opposite? What can happen to you and to others if you don't know how to make those clear and concise conclusions from data that you've gotten?
You wouldn't be able to assess the risk,
Right. Exactly.
like overload of information.
Yeah. You wouldn't, excuse me, losing my voice here. Yeah. So you would know the risk of the information that that would clearly interfere with your decision making ability. So, excuse me. So yes. So some information, misusing information to prove an ulterior motive. We see this all the time. If you are ever on social media, you know there are a lot of people you misrepresent facts and data for their for their own biased purposes. Um, if you miss one step when you're working with data, You missed that one. The whole thing is wrong because you missed that one step. So you have the risk of just completely misusing the data. And of course, if the benefit is that you can make good decisions, the risk of not being data literate is that you can't make good decisions because you can't recognize what's good and what's not. And you can also end up spreading misinformation or harmful findings to others. And we hear a lot of that, especially when it comes voting season will be coming up. And so you'll hear a lot of that about people manipulating data. Oh, have someone else coming in. About people manipulating data for their own biases. So welcome. The person just came in. Okay. So we talked about the benefits, the risks, why you should care. We're going to do this example. So here, let's just say this is your family. These are the ages. Um, there are 10 individuals in this family. Just looking at the numbers, what is the average? Is it in the 20s, 30s, or 40s? And of course, the average is the number you get when you add up all the ages and divide it by 10 because there are 10 people. But
It looks like
just by looking at it, what's the average age?
30s, like 30 to 35. It looks like.
Yep, very good eye. So it's actually you right on the point. It's 34.2. It's the average age. And why is that beneficial to be able to look at something and get that? Yep, Maria 30s, exactly. Why is it beneficial to just be able to look at this?
It it gives you a visual image of like so you can see how many people, were in the space or how many people showed up at the event or how many people of that age group showed up at the event.
Right. And so you were given the ages. Right, Ingrid. Just straightforward data. Um,
Hmm. Okay.
but yeah, how do you pronounce your name? Amina?
Or Amina, but Amina, yes.
Amina. Okay. Yes, exactly what you were saying. Because somebody else, they'll give you this, if you don't pay attention to it. It's like, oh, yeah, that. Um, the average age was in the 20s, because especially in advertising, marketing, that's a good age that's the age group they really try to market certain things. Or if they said the 40s for if there was something for seniors or something like that. No. So just being able to do a quick glance and estimate that can be very beneficial to you in the long run. Now, there are some outliers here. You see grandma's 88, the great aunt 70, and then at the bottom. But for the most part, you have more people in this age group from aunt to dad. So that's a good indication. These outliers kind of balance out. So that's how you end up with it in the 30s. Okay. Okay. So now I just want to show you a few examples of how people try to mislead you with data. Sometimes it looks good. And you think, oh, okay. But no, there's some tricks here and there. So we're going to look at a few of these charts and graphs. And then after that, I have a couple examples and I'll show you how you can use a couple of our resources to find the actual data and charts and tables. Okay. Now, this before the truncated y-axis. Of course, the y-axis is the vertical line going down. The before is incorrect, the after is correct. What's the difference that you see? What's the difference between the y-axis?
What's the question you're asking?
Uh, Maria said one of the graphs has a zoom in, the other shows more numbers. Right. Now, I was
Hmm.
asking, what's the difference between the y-axis?
The numbering. Right. Yeah.
Exactly.
Yeah.
So,
Where it starts off at. Yeah.
yeah. So the before, this is incorrect. And so why are they doing this? Because if you look at the after, there isn't a big difference. So of course the y-axis, it should always start with 0, where the y and the x-axis meet. This one, they started at the top, like where this one is, and just went up every 5 degrees, 5 points up. But look at 2014 and 2015 here, it looks like there was a slight difference. You can say, oh, well, here, if they're trying to say there was an increase in something, um, try to fool you as though there was an increase in whatever data they're presenting.
You wouldn't know because if it didn't start at zero, it could be negative or positive, you know?
Right.
Yeah.
But one of the reasons why, people try to trick you with graphs is it's visually more appealing. Um, you can just look at it. If you're not paying this any attention, you just look at this and you say, oh, there was a slight increase. But of course, here, there really wasn't a noticeable increase. It could be less than a half% or something like that. So always pay attention to the how they number it. Um, because they're trying to fool you as to think that there was actually a difference from year to year. But if you see these labeled correctly, there isn't. Okay, so here they are misusing the dual axis. Of course, same thing. One of the same things here. They're giving us two figures, and here they're trying to say, oh, there was such a sharp decrease in cancer screening, and they're trying to tell us that there was, uh, abortions are up through the roof. But what what's wrong with this graph here? I'll give you a hint. Look at the numbering. So it's like they're trying to compare apples to oranges. It's not giving enough information. Okay.
Hmm.
It's not in order. Yeah.
And
So
it,
what information would you like to see on here to the person who said it's not giving enough information? Because there are a couple of things wrong with this one. So again, there's no y-axis. There's no starting point.
it's well,
Yeah. Oh, the number of abortions. Yeah. There is an increase, but it may not be as drastic as this line shows. The other thing is the cancer screenings are in the millions. These are in the thousands.
and it makes, yeah.
So in some tables, you see they have a little note that they will modify the numbers to where, like, you have to multiply by something because they've made them even, or they put them in the same denomination, so to speak. So if these are in the 100,000, this should be in the 100,000s somehow. So let's look at the correct. Okay, so you have the y-axis, The cancer screenings are down. That is dramatic. But look at the number of abortions. They are up, but not as up as this makes you think, right? So that's someone who's probably trying to make a point. Because this looks like you went from like 200,000 abortions to 500,000 or something. But there just was a small increase from that time period. Yeah. So again, they just plot these graphs. They just put it anywhere. You don't know what it means or anything. So okay, and this is the last one I think we're gonna look at before we do some fine statistics of our own. Now, it's if you're comparing two things, it's not usual that you will find two pie charts next to each other. And why do you think that is? Can you immediately see the difference from chart to chart? But you might be able to. You all are young and you have sharp vision. Yeah, it's so close. And visually it doesn't make it easier. So if you're using visuals, normally you do that to make it easier to make your point.
That's why you have to focus on the details and the numbers, because
Hmm.
that's how they'll trick you, like you were saying. You could
Yeah.
look at it and just automatically think both of the numbers
Hmm.
should be even. Yeah.
And so here, this is the same information, but so it matters how it's presented. Okay. This makes it a little easier. You can see the difference for the USA, for China, for all the countries. You can see whether there was an increase or decrease from, we'll just say, year to year. So if you're comparing two things or 2 years, more than likely you're going to use graphs and not that. That's not visually what you need to make your point. Okay. Any questions before we go on? We're going to get to a couple of databases. Um, so you may have papers coming up and you want to incorporate some tables. You have a lot of simple data that you can use for most things. Okay. So we've just looked at how to spot errors on the manipulation by paying close attention. Um, but now we're going to look at how to verify that information. Um, because even when people do it correctly, where did they actually get the information? That's important as well. Because, I mean, you could make this in Word, just throw some numbers in there and to make your point. But let's focus on how to find and verify data. And we're just doing simple data. We're not doing data sets or anything like that. Okay, so let's find the examples. Okay, so take a look at this. This actually appeared on a news website. Food, food stamp fraud is at an all-time high. And notice in this sentence, and even here, where SNAP is the other name for food stamp, which is, what is it? Supplemental Nutrition Assistance Program. Yeah, that's what it stands for. So notice here, according to the USDA, 70 million of taxpayer money was wasted in 2016 due to food stamp fraud. Okay. So what two questions immediately come to your mind, or at least one question? One thing could be, is this 70 million number that's wasted, is that correct? That's one thing. And the other is that enough to justify, how is that even possible in calculating if they are using it for food? I'm not mad. Right? So
But how was it wasted when it was used?
for fraud. Yeah. I,
Mm,
I guess we had to find out more information about that. Yeah, we all agree on that. As long as it was used
mm,
for food, but I guess maybe some people who weren't supposed to get it got it, you
I
know.
know, trust me.
But, if you're like me, like you say, if it's used for food, who cares? We all could use some. It should be
Yeah, but
given to
after
everybody.
people transfer it to cash money.
So if we want to verify this, uh, one thing is we could go to this organization, this government agency, USDA, and see if this that 70 million was actually accurate. But the other thing to consider is in this case, because they're saying because it was wasted, this 70 million, we need to shut down the whole program. Well, how many other people, if you shut down the program, will be affected? How much in total did the program spend? Because, yeah, 70 million is a lot when you're thinking about my bank account, but for the government of the US, maybe 70 million isn't that much. So I'm going to stop this share here. And I'm going to, let me find my screen. One second. I need to, and again, I am going to send you this link at the end with this research guide. So right now you're looking at the research guide that I have. We're going to look at the databases, but first, I just want to point out anything that's covered by a government agency, you can start here at usa.gov, and I think I could just put in SNAP because that's the name of the program, and it takes you right to it. The other thing is because we could have gone USDA, and we can see that it's actually coming from the USDA. We could have gone USDA.gov, and let's see. Okay, data and no programs, data and research. So okay, SNAP is a program, so let's look at program data. And I'm just going to one. I forget which one it is. No, it's the other one. Oh, here it is. SNAP tables. Let's go there. And this is giving me numbers in PDF and Excel. So you could download the Excel if you want it. I'm just going to go to the PDF. Okay. This is telling us the cost of each, the total cost of the program. This is in millions of dollars. So whatever this number is to the right, you will multiply by 1 million. So 69, let's go down to 2022. It's the last year. Okay. So this number you multiply by 1 million. I didn't do the math, but that's a lot of money. I can do it right now. Hang on. Times, oh, my little calculator can handle that. Okay, so it looks like it looks like you may be in the billions. So you multiply this times 1 million. If your number's in the billions, then 70 million, while it seems like a lot, it is a lot actually, especially for us. But as far as the government, it's not enough to cancel the entire program because you still have um, almost $1 billion being spent on other people. So you don't want to do that. Okay. So anytime you're looking for statistics that may be from a government agency, you can also go to data.gov. You can find the agency here, usa.gov. But I want to show you a lot of this is in one of our databases, Statistical Abstracts of the United States. And this one is the first one that I like to go to for most tables. And notice here you have all this basic information covers a lot of areas. And most of this is data from the government. Um, okay, so I'm going to do another search. Let's just say SNAP. Okay, so again, we have these tables here. Now, the other reason why, yeah, we found the information on that website, the governmental website, but here I'll show you why I like to use this. Okay, so we have this is divided on something else, but let's just pretend this is the table we're going to use. It tells you where it got the information from, so you can go right back to that website we was on. But also, if you put this in the paper, it gives you the citation format for APA and MLA, which I don't know about you. If I don't know how to cite something, I may not use it in my paper. So here it actually gives that to you. Just copy and paste. And then you can actually download the table if you want. So how many results? So 11. If we just wanted to look at the food stamp program, we can just limit it to those 6 tables. And this is actually the one that we want. So notice it's telling you 40,302 represents 40 million. So the same here. That represents millions. Okay. So from that heading, it looks like there was probably someone who I'm going to get back in the PowerPoint. Let me share my screen again. Okay. So you think that this organization maybe has some ulterior motives? Maybe they don't want government to provide any services, so that could have been a motive there. So we verified the data and we found that, hey, even if $70 million was wasted in fraud, enough of the program is still helping a lot of people. So it may depend on, your philosophy. It may or may not be worth keeping. Okay, let's look at this one because this. I was trying to find something that I found on my actual social media because I know data on social media comes up a lot. So here, I don't follow this person. It just randomly came up on my Twitter feed. I'll just read it. Now, this person, they're saying 3,573 women were unalived in 2020, and 1,440 of those victims were Black women. And notice he says they're saying roughly 40%. And since we know how to guesstimate, as we did earlier, calculating the average, here we're just looking at, okay, that may be almost 50%. So 40%, maybe that is right. But this person goes on to say Black people only make up 13% of the population, and Black women make up half of that. What does that say about the rate at which Black women are unalive? So, what is this person trying to say? The first part is okay. If this is indeed the correct number, but we're going to verify this stat here. If there were actually this many of people, this number of women who were unalived in 2020, we can find that, and we can also find this number.
Mm-hmm.
But what number? What we need to find out is this. What a
13% of what the population?
Yeah. So what number do Black women make up of the population?
It
Just
says
just guessing. Is that going to be in the hundred thousands, millions?
that's probably going to be in the millions.
Right. So now we can say that we know that this is wrong because he's trying to say that half of the Black population are in this data, but only 1440. So this is made a point here that Black women are 40%, but this 40% isn't half of the Black women population. Um,
Yeah.
so if you're not paying attention, you could get all up in arms like, oh my goodness, half of Black women are being, taken care of, not taken, unalive each year, but that's not entirely true. Let's go back to that database. Again, I'm in statistical abstracts. Let's start over. Okay, so if we want to find out, and we can just go here to population because what we want is the population of Black women. So we could start here under population, men, women. We could look at women there. Okay, and we could just go through those tables. I'm going to just search. Let's say, okay, population and race. some of the same tables came up. So let's see. Population. Okay, so females, one race, black women. We can come all the way over here. Now, even if this number did just represent 23,000, we know that the point he was trying to make in that post was wrong. But here, again, I think you have to add a couple more zeros to each of these numbers. Let's see, how many zeros did they add? It's 3 zeros. So really, 23. There are 23 million black women, right? You see that? So that part of we knew that number was off because there's no way that 1440 is half of the black women population in this country. But we want to verify that number of total women who are unalive each year. So we're going to do another search. And let's see, what am I going to search? Okay, here it is. Homicide and race and sex. And anytime you're combining keywords, you have to say and. So that's why that's there. Okay, 2020 total. So these are divided by race. So I guess if you add white females versus black females, you get close to that number that they had. Sometimes the numbers may be off depending on, like here, make sure you read the notes that they have. This excludes non-residents of the United States. Okay, so if we go back, okay, 2019. So there's that 35. Let me make that bigger, make sure you can see it. The number of female, we verified that number, 3573. Let's go back to the, okay. So one other thing to look out for, notice he said 3573 in 2020. That's not entirely wrong because sometimes the mistake a lot of people make is that number was probably published in 2020, um, but it takes time to compile data and publish it to the public. And so usually when it's published, it's for the year before. That's another slight mistake they made in this post. I'll just stop here. Any questions? Okay. Let me stop. And the last thing I want to show you is similar to this. Let's do, I'm going back to the research guide. If I can find it. And again, I'm going to send you the link to this, so don't worry. I just want to point out a couple of things here. We have Roper iPoll. This is contains a lot of political opinions, and you'll see a lot of this. I'm just going to do a search. Uh, my computer isn't freezing up.
Is this like a website through the library, the Roper iPole, or
Yes, it's
no?
another database.
It's in the database. Okay.
It's another database. A lot of times you see articles from AP and they'll say, "Oh, this we did this telephone poll with these amount of voters." So this is the place you can come to verify that. Let's see, election. I'm gonna say election fraud, and we're gonna search. And so what they gather here, they go around asking questions. Some of these are from newspaper organization. Uh, like here, which of the following topics are the most important issues facing the country? So if somebody said, "Oh, 90% of the country is concerned about election fraud," you say, hold up. That's not true. Only 17%. And this survey was done in August of this year. So, and it has the site here. So you can just copy and paste that into your paper. So there are thousands upon thousands of questions that you can find in there. Again, all of these are opinions. They've gone out telephone polls. Sometimes they catch people in the mall and do ask questions. You've probably been approached before and didn't know what it was for. And lastly, I'm going to show you this Social Explorer. And remember when we was talking about visually appealing um, data? This this one does give you tables that you can put in your paper, but also if you want to look at how it appears on a map, we're going to go again. This is Social Explorer, and we're going to explore the United States here. You have some other options there too: COVID, crime, health data, and election data. So you can find all of those and represent it visually, graphically. So let's explore. Okay. So right now the data is population data, but I can change this. But notice how you have your little code here, the darker, the higher the population, but you can get the number for each total population for each state. But if we change it, there are a lot of different things we can look at. And let's look at education. Highest. Let's look at for the population 25 years and older. And notice, well, that's kind of a mess there, but we can change this and say dot density. And you can see how educated a state is. Well, that population over 25 in that state. How educated those folks are in each state. Kind of sparse out here in the Midwest, or Northwest, that is. So this is just something you can play around with. I want to, those are the tables we just looked at. If you want more detail, are you going to use that? Yeah. If you want to know more detail about what those databases can do, if you want to know how to find data sets and create your own data. We have a whole team that helps you with that. Um, this is their web link. You can see there. I also have this on the research guide. They also do uh, they do workshops. They meet with students one-on-one, and yeah, they have recordings and workshop. If you have a question, they also help you with the software for data. So if you want to know about SPSS, SAS data, R in Vivo, which is the software you use when you do focus groups and interviews. You have the qualitative data. So there's a whole team here that can help you with that. And they also have, yeah, here's the software that they help you with. Yeah. But for most of you, if you're undergrad, first year, second year, incorporating a table or two might be enough. So, but when you get ready to move on up, you can reach out to that team.